In this video, we're going to look at some examples of trig substitution integrals involving the secant function. In this example, we want to evaluate the integral of 1 over the square root of x squared minus 16 dx. Since this integral contains an expression of the form square root of x squared minus 16, or the square root of x squared minus 4 squared, we're going to use a trig substitution with a secant function because the expression in the square root is a variable squared minus a constant squared. And in particular, because that constant squared is 4 squared, we're going to let x be the 4 secant theta. And this will be the substitution that allows us to evaluate this integral. Well, once we have x to be that, we know dx is the derivative of that, which is 4 secant theta tangent theta. And we also want to evaluate that denominator of the square root of x squared minus 16. And so here we substitute in 4 secant theta for x. We see that that becomes 16 secant squared theta minus 16, all inside the square root. We can factor out a 16 to get 16 times secant squared theta minus 1. Using a standard trig identity, we know that secant squared of theta minus 1 is tangent squared of theta. And now we evaluate this integral. The square root of 16 tangent theta is going to be 4 times the tangent of theta. And now we have all the pieces that we need to substitute into our given integral. So 4 tangent theta is going to be substituted into the denominator for the square root term. And 4 secant tangent will be substituted in for dx. And so once we make these two substitutions, we'll have an integral in terms of theta, which we can then evaluate. So we start with our original integral of 1 over square root of x squared minus 16 dx. And we substitute in 4 tangent theta for the square root expression in the denominator. And also we substitute in 4 secant theta tangent theta d theta for dx. At this point, we get some simplification. Of course, we have the constants 4 that will cancel out. And we also have a tangent of theta that will cancel in both the numerator and denominator. And so we are left with simply the integral of secant theta d theta. Everything else here cancels out except for one factor of secant. Now, the integral of secant is one that we know to be the natural log of the absolute value of secant theta plus tangent theta plus c. And so all we need to do to finish off this example is to go back to x by considering a reference triangle and finding the secant and tangent of theta and substituting them into this expression. So we recall that we made the substitution x equals 4 secant of theta. And from this, we divide by 4 to see that x over 4 is going to equal the secant of theta. And that is one of the two expressions that we needed to evaluate in terms of x. And so we can replace secant theta with x over 4. To find the tangent of theta, we're going to use a right triangle. Again, we have this right triangle here and an angle theta as one of its angles. And we're going to use that the secant is x over 4. Well, the secant of an angle is the hypotenuse of the angle over the adjacent side. Alternatively, you can think of the secant as the reciprocal of cosine. So the cosine would be 4 over x. And so the 4 would be the adjacent side and the x would be the hypotenuse. In any case, we would end up with the triangle here. The Pythagorean theorem will tell us that our third side, the opposite side of theta, will be x squared minus 16, the square root of that expression. So the square root of x squared minus 16. And from this triangle, we see that tangent of theta will be the opposite side, the square root of x squared minus 16, over the adjacent side of 4. So we get the square root of x squared minus 16 all over 4. and this will get substituted in for the tangent of theta. And so our value of our integral here will be the natural log of the absolute value of x over 4, that's the secant of theta, plus the square root of x squared minus 16 all over 4, quantity plus c. If you'd like to try a similar example, pause the video and evaluate the integral of x over square root x squared minus 4 dx. Resume the video in a few seconds to see a detailed solution. Since the integrand contains the expression square root x squared minus 4, we're going to make the substitution x equals 2 secant theta. And from that, we see that dx will be the derivative of that expression, which is 2 secant theta tangent theta d theta. And the square root of x squared minus 4 simplifies to 2 times the tangent of theta by substituting in 2 secant theta for x and squaring that expression, factoring out of 4, replacing secant squared minus 1 with tangent squared, and then computing the square root of the perfect square. We substitute x, the square root of x squared minus 4, and dx into our original integral, and we obtain the integral of 2 secant theta divided by 2 tangent theta multiplied by 2 secant theta tangent theta d theta. 2 of the 2's will cancel out, as well as the tangents, and we are left with an integral of 2 secant squared theta d theta, where we can factor the 2 outside of the integral. And we know an antiderivative of secant squared of theta is tangent of theta. And so our integral in terms of theta is going to be simply 2 tangent theta plus c. Now, of course, we do need to go back to the variable x, and to do that, we'll use a reference triangle. So going back to our substitution of x equals 2 secant theta, we know that x over 2 will be equal to secant theta. And using a reference triangle, we can find the hypotenuse to be x and the adjacent side to be 2. And the third side, the opposite side, will be the square root of x squared minus 4 by the Pythagorean theorem. From this reference triangle, we find that the tangent theta, which is opposite over the adjacent side, will be the square root of x squared minus 4 all over 2. We then substitute this in for tangent of theta in our integral, and we get 2 times the square root of x squared minus 4 over 2, all plus c. And of course, the 2's easily are seen to cancel, leaving us just with the square root of x squared minus 4 plus c.